I hate it when they do that. Okay. So, vertex is at 3, -1. Focal width is 4. Absolutely no ifs, ands, or buts about those two. Those are automatic. Now, the other two require a little bit of effort. So, 3, -1, there's my vertex. And in order to answer the other two questions, we have to figure out which way this opens. So, what do you think? To the right. Absolutely to the right. How do we know it opens to the right? Y squared, positive number. That's right. Now, that means that my focus is in here somewhere. And my directrix is back here somewhere. Do you agree with that? And I can find those things if I just know how far to move. And that distance is always P. What is P in this problem? 1. Because 4P is always that number. So since 4P is 4, P must be 1. So I'm going to start right here, and I'm going to march forward 1 unit. Okay, so pretend you're on graph paper, which I have up here if you need it. You start here, and you take 1 step forward. What will be the coordinates of that point? 4, -1. Yep, that's your focus. And if we took 1 step forward to get our focus, we're going to take 1 step backward to get our directrix, right? And where will that be? Again, think about your graph paper. You're right here, and you're going to back up 1. Where is that? That's where your x is 2. And we're crossing the x-axis. That line is x equals 2. Okay? Friday's quiz, I'm going to throw a parabola problem on it too. So it'll be the circles we practice first. I'll throw one of these on there. All right, the good news is about Friday's quiz. Where are we during class on Friday? We're going to do it on the bus. And we do it on the bus. And we're going to do it on the bus. Yeah. Always have a bus quiz, and we do it together, okay? So, be ready for that. I have the pencils and the papers. I got everything you need. Do not worry. But, yes. All right, so now we're going to spend a couple minutes here, and we're going to talk about the third conic section. Remember, there are 4. We've already done circles, parabolas. Today we're going to talk about the ellipse. The definition of an ellipse: set of points in a plane. They all start that way. All your definitions start that way. Set of points in a plane. The sum of whose distances from 2 fixed points is constant. Now, right now, that definition is blowing your mind. Don't worry about it. You're gonna see what it means here in a second. Kendrick, who signed this pass for you?
Close to.
Okay, now, vocabulary word. These two fixed points are called foci. Guess what foci is? The plural of focus. There's two focus points in an ellipse. Okay, I'm gonna show you how to find them, I'll show you where they are, it's real easy. Let's take a look at our first equation. Okay, now wait a second. First of all, it can't be a parabola because it's got two squares, right? But so do circles have two squares. What's different about this equation than your circle equations? These guys have these weird denominator things going on, right? That's how you're gonna determine an ellipse. It's gonna be x squared over something, y squared over something equals 1. Every ellipse I give you is gonna be in standard form, so it's gonna have that format. Now, caution, there might be parentheses up here, like this. Just like there can be parentheses in circles and parabolas. If there's no parentheses, like in this problem, no parentheses, where do you think the center is? If there's, look at the numerators. Only the numerators for the center.
Origin.
The origin. The center is going to be at the origin. If I put an x minus 1 or something squared up there, that would move it to positive 1. But it doesn't have that, so my center is just 0, 0. Just like with the parabola, just like with the circle, if there's nothing, if there's no parentheses, you're at the origin, or you're 0, okay? Now, see the 16? He's under the x. The square root of 16 is 4. I am going to start at my center, and in the x direction, I am going to count over 4 and left 4. This is how you graph an ellipse. Start at your center. The square root of that number is like a radius. You take the square root of it. The square root of 16 is 4. It tells me to go left and right because it's under x. X is the left and right direction. So what do you think this guy tells me?
Up, down.
Up and down, how much? 2. The square root of 4. So I'm going to go up 2 and down 2. I'm going to connect those. Don't make a diamond out of it. Make a nice rounded thing. And there's your ellipse. That's what an ellipse is. That's the shape of an ellipse. It's like a circle, but it's been squished. It's like an oval. That's an ellipse. These 4 points, the directions say, find the center, we got that. Find the vertices. Those 4 points are the vertices. So negative 4, 0, 4, 0, 0, negative 2, and 0, 2. There are 4 vertices that you're going to join and make your oval. This, I mean, obviously, this particular ellipse is longer this way than it is this way, right? It's stretched this way. The long one is called the major axis. Major, big. So the length of my major axis is how long? How long is my major axis? 8. Kids, you went 4 each way, that makes 8. This one is called your minor axis. And how long is your minor axis? What if the major and minor axis were the same?
Be a regular circle.
You'd have a circle. And that would mean these two numbers matched? Yep. Then it wouldn't be an ellipse, it'd be a circle. What else do I need? All I need, the other my foci. Your focus points in an ellipse. This is the last problem we're doing, hang in there. Your focus points on an ellipse are always somewhere on the major axis. Okay, I'm not grading your picture, just put it there. They're somewhere on the major axis. Your job is to find these 2 points. Now, since I went straight left and right for these red points, I'm going to go left and right. Is my y going to stay 0? So even just by using your common sense, using your graph paper, go left and right, you're still y is 0. You got half credit right there. The distance in an ellipse, and this is something new to remember, the distance in an ellipse from the center to the focus, center to focus distance in an ellipse, in this one is the square root of 16 minus 4. Now, where did I get the 16 and the 4? The denominator. So it's always going to be the denominators. You're always going to subtract them, and you're always going to take the square root in an ellipse. So that's going to be the square root of 12, which is 2 radical 3. Center to here is 2 radical 3. Well, isn't that x 0 right there? X is 0 plus 2 root 3, 0 minus 2 root 3, and there are your focus points. We will do many more examples next time.